Thank you very much. Thank you. Thank you, everybody. My name is Daniel Clement. I'm a cloud solution engineer for ACS Ghana, and also a cloud community developer, and also a policy advisor for Atlantic Council in the US. Yeah, so it's all about competitions, cyber competitions, and of which I give advice on. So basically today we'll be speaking about modernizing telecom security using AI, ML powered approach. And this particular solution basically is a build-on of an existing technology where we have already. So what am I driving at? What I'm driving at is that these days, telecom industries are finding ways and means to safeguard their system when it comes to interactions with human. And we all know that humans are the weakest link when it comes to technology. So this section is basically going to see how we can use AI to make sure that we keep all the security in checks and making sure that telecom industry gets the best of what they need to grow their business. So looking at the agenda, overview, security risks, telecom, and why AI, economic implications, case study, a demo. I wouldn't be able to give a live coding, but what I've done, and I'll show you what I've done because of the sake of time. Mitigation framework, key takeaways, and we are off. So in recent times, the number of transactions we do, basically, as for me, especially coming from West Africa or in Africa, and a bit of research I've done within the Chinese and also the Hong Kong industry, you could see that people day in and day out rely on their phone to make transactions. And as a result of this, there are a lot of scams going on, either from text message or voice. Okay, but this, what we are going to talk about is going to build on voice, not on text, because text have been built to the, should I say, a perfect stage, where now you wouldn't want to find maybe incorrect spelling of words. Everything is fine, but it's fraud. Okay, so online transactions continue to rise, and as you look at the numbers, so 1 trillion annually, which is going to be estimated by 2027. And this is huge, actually. And there's an increase in payment scam. So there are 1.5 billion of this fraud, or this money is being lost to fraud as of 2023, when the research, the research was being done in that direction. And most of it, or 47% of this transaction, has been based on what? Has been based on transactions that we make, whether online or physical or voice. And since it's a worrying alarm, or it's something which is very worrying, industries are trying to find a way to do what? To plant anti-fraud system within their system or within their data. And what they are trying to do basically is to do what? To make sure that they enhance maybe two-factor authentications, they do behavioral analytical checks, they do maybe risks within their core system. They have risk engine to make sure that they track all this pattern-based stuff. But pattern-based stuff are not to me, are not to its highest in terms of protection, because it's protected to a certain level, but what about the rest? So you look at it, we're looking at it. So what they are doing basically also is about that is also to do tokenization and de-tokenization. So making sure that when, I've worked in a fintech company before, so when you send the money, to keep those traffic maybe secured, they make sure that they encrypt the request, and also they make sure that they do something tokenization. I wouldn't want to go much into those stuff. And when the money gets to you, then it de-tokenizes, or it does what? It encrypts. It decrypts, and that's the way we are doing. On that is the way it's still alive. So fraud detection and prevention. So what they are doing again is to do what? But what they are failing to do, the challenges in this sense, is that in terms of the security intelligence, they are still lacking behind because they need to catch up with new fraud, attacks, where attackers would want to make sure that they break into the system, because day in and day out, when you build a system to protect a system, there's a new backdoor to that particular system you've built. So they are finding challenges in making sure that they adapt to this challenge. And also, in an extent, they also don't know how to make sure that, even though they have a proper way of building that system to keep it very secure, they're also thinking about how is legitimate traffic or customers going to still be in the lane whilst we make sure that we block these bad actors. And that is also a worry or a concern in the telecom industry. And lastly, it's basically about monitoring. So even though they have SOC analysts and a security team to make sure that this system are being in place, but certain times it's beyond these new attacks or this new threats, is beyond deny or allow rule-based, and this would make sure that it passes through the system without the system being able to identify them. And we just see a lot of AWS tools to also help us to identify this kind of tools, this kind of risks. So looking at the risks vector, there are so many, but these are the three that I've highlighted. Sorry for the numbering. Which I've spoken before, the traditional method. So the traditional method is basically allow or deny. So we said maybe if it's our network VLANs, put maybe a set of IP address in one VLAN. If it's the other way around, making sure that two-step authentication, or just basically allow or deny. And it has even to an extent is good, but in this modern age where AI is taking a lead or machine learning is taking a lead, it breaks those rules and creates more loopholes into the system. And this is going to be based on what our solution is being defined: evolution of deceptive vectors. And when I say this, it's basically about, now the new trick to this effect is voice. So they try to make sure that they influence you, social engineering of course, making sure that they deceive you in sending an amount of money. Maybe I'm speaking from the government, or maybe you order for this item, of which maybe you didn't do it, but maybe you thought to yourself, okay, fine, I'm getting this item, or maybe fine, from a family member, why don't I just accept the request, and you are scammed. And this is the worry need, and the need for AI and machine learning to address this is what my solution is going to talk about. And lastly, too, historic flaws re-engineered with contemporary delivery method. And if you're familiar with the telecom industry, there are basically two protocols, which is the SS7 and also the SS7, basically the other one I've forgotten about it just now, I don't know. So basically it's the way of which maybe you guys are staying in 5G, but in Africa or part of Africa still rely on the 2G, 3G, 4G technology. And this particular SS7 dynamic threat protocol, basically it's making sure that users or hackers or bad actors doesn't intercept the communication of somebody on the 2G or 3G or 4G network to the other side. So basically making sure that, okay, let me say this, the build-up of the 2G and the build-up of the 4G was making sure that traffic from 2G and 3G wouldn't be intercepted. So, and to an extent, it's red. But in this current age, those people are still using the 2G and 3G. So it means that this attacks is still ongoing, and we need to fix this. Sorry. Okay. So why AI? There are so many benefits of AI, but just speak a little bit about this. So AI can help by making sure that, or AI is an enabler in making sure that we train machines to hear lies. And lies are what? Are the conversations that the hacker would make with you, seeming is true, but it's not true. I know it's a very difficult one, because if, let's say, my mom is talking to me, or someone from a legit company is talking to me, how would I identify that there's a scammy language, or maybe this person is a scam? And we'll look at the solution. Let me say, we'll look at the solution there, because I'll be talking much on that. On that. So AI will be able to what? We're able to make sure that we identify this threat, or this analysis, or these patterns within the conversation, and do what? And safeguard our system. And most importantly, AI is also what? Continuous learning. So at every point in time, there's a new attack, there's a new solution in order to fit into that attack. Yeah. So economic implications, which is very, we'll say very fast. Obviously, it's going to lead to revenue, what's it called, leakage. Company will suffer or go bankrupt. And trust as a currency. So I talk about trust as a currency in terms of now people or customers wouldn't have trust, because you don't want to be in a bank, you don't want to bank with a company, you don't want to bank where your money is gone and you want to invest there again. Nobody wants to do that. Everybody wants to make sure that the system is very secured. So now you would lose that happiness in investing into that company. Very interesting. Let's look at our solution. So designing this is in place. What the solution basically is doing is that, so there's a telecom side of it, because in the telecom industry, certain things or core systems have not been moved to the cloud. So you still have this on-prem legacy stuff running up. So I didn't include that in here, but the original flow of this diagram would be from making calls, so either from radio wave, satellite, or IP address calls. Then it will be routed to what? It will be routed to, obviously, the tower. And after being routed to the tower, even though it's not here, after being routed to the tower, it will be converted, it will have what's it called, a converging point as the media converter before it can be translated into this environment. Okay, but those technologies that have been based on 5G already can easily integrate with this architecture. But those on the old stuff will still have to pass through this line, which obviously we're going to cause a bit of latency. So what am I doing here? So for instance, the person gives you a call, and the transcriber will capture this suspicious voice. So after it's being captured, it would check in, or to check I call it a book, or I call it a custom keyword. So these custom keywords are some of the keywords that obviously would pop up within a conversation, like give me your PIN, or we need your PIN, we need your bank details to check one or two things, making sure that the things are secured. So all these kind of keywords would be preloaded into the system as a first point of call, so that at this point where users would make sure that those conversations would begin, the identification of those keywords would be captured. Then they then move on to the AWS comprehend, where it's very, very important, because the AWS comprehend here, which I've said scammy language, would have, or would make sure that we have a defined behavioral analysis of what is going on. So making sure that it's identifying the tonation, identifying the hastiness of the conversation the person having with you, more or less. Because obviously when maybe a friend of yours is having a conversation with you, it'll be on a lower tone, and maybe you are frustrating somebody who is a bad actor, would want to give you that kind of voice that would make you think maybe there's something going on wrong here. So the comprehend would make sure to identify those sentimental analysis, of which I've mentioned right now, together with the keywords already being preloaded into the system. And this traffic is being sent to the AWS SageMaker, which I've identified them as custom models, where it has is doing a partial model training. Why I say partial? Because this system is a real-time system. Whilst you are making the phone call, it's being identified, and a message at the end of it all will be sent to you that maybe this conversation you're having is a fraud, so maybe check back on it, or to the highest level would end the call, so that it more or less will frustrate the the hacker and move on to the next person, and it happens to the next person, the frustration continues, and that will be it. So when it passes through the model, it has a low level, even though it is a high level, a low level of the event flow, where we have the event bridge. So the event bridge signifies the custom fraud logic. So where you have so many lambdas behind or under the loop, making sure that, okay, if, and I'll show you the code for it, if it's the neutral maybe detection, this will happen. If not a neutral detection, this will happen. If it's a fraudulent, this will happen. So the lambda takes care of all those things, and obviously sends a trigger, and the user gets information in that perspective. And the retraining bucket is making sure that all those conversations that probably didn't get a way to be checked would now be saved within the S3 bucket and be retrained. So more or less creating unsupervised, at the end of all, creating an unsupervised learning within the system. So it will get to some point, it wouldn't be, we have to identify a keyword, it will learn from all those conversations that I've had previously, and it's being stored. So for the system visibility, we have the artifacts for compliance, CloudWatch for monitoring of the logs and whatever is happening in the system. The guard duty is in charge of the model behavior, so making sure that at any point in time, not only static configuration being made, at any point in time anything changes within the system, maybe secure injections or whatever thing happening within the system, it identify it, because maybe I'm setting A into the system, okay, and now there's A, B into the system. Sometimes this rule base wouldn't identify it, but with the help of guard duty, which helps in identifying model the behavior of whatever your system is being in place, we're able to do what? We're able to identify these changes within the system. And the AWS Prowler is, I call it AWS Prowler, even the open source tool, basically helps to identify the static analysis, or give you the static analysis of a configuration, making sure that you don't maybe give over permission of whatever is happening within the system, or allowing more rules to a particular service, because at a point in time, AI, when implemented into your system, would make you allow what's it called, match permission to some of the permissions already existing to your system, because sometimes it wouldn't fit into that bracket where you want to do maybe view only or maybe read only. So it does those checks for you. And basically for security, AWS config keys to manage your keys, and the Mesa to do what? To manage the PII, because obviously I'm making phone calls, the conversation and all those things. So one concern reason now here is to, and that is for the telcos, is to make sure that either the information sits on the telco side, or that is the PII, or those encryptions data and all those things, while the process runs through the cloud, because obviously telecom industry is very sensitive, and you don't want to expose your data to other people. So the design is basically either to keep it at the telecom side, or to keep it in the cloud. But what I've done basically is full cloud in that implementation. So the telecom industry can either to do it that way or the other way around. So a demo of walkthrough, very simple. I'm just showing you what I'm implementing. Okay, what's up? Yeah, sure. So we have all these conversations ongoing here. So identify all this. I'm not sure it's going to play. Okay, let me see. Okay, it's not going to play. Okay, sure. So these are various conversations I've recorded. Okay, and these are the phishing data. So non-phishing, you can see non-phishing voice recording and phishing voice recording. Okay, and when I'm using Terraform obviously for the deployment. This is a sample code of that. But the most important one would be the Lambda. Okay, so you could see the SNS topic is based on SNS topic, basically on the event being triggered. So okay, sure. So these are the fraud keywords. So reset your PIN, confirm your account, last for the gate, confirm your account number, and the rest. And we are setting a suspicious what's it called, margin of 0.5, or else it's safe. So if it's 0.85, that means it's fraud. But if it falls within the 0.5, it means it's safe. So based on the matching keywords being defined. Okay. So Docker for those, and the transcribe. So when you come to the transcribe, these are some of the things that I'm doing. So you transcribe, you see some of the words being populated. So please confirm your account number. Remember, we have a keyword called account number there. What is the last 4 digits of your card, and all those things ongoing on within the system. So this is how, even though it's very short, I'm sure because of time too, this is how the system is being configured to making sure that it identify all those conversations and making sure that it makes use of making sure that it prevents the system from being hacked. So what are some of the mitigation framework that we need to know? So most importantly, we now have to treat our line, at least for developers, and also for implementers, or for business people of high authority within the telecom space or within any industry, to now define policy as a code with AI in the mix. So even though AI in the mix, the reason why is because not every code the human being would be able to grasp or keep updated with, or be able to go through them. So AI will play that bit of making sure that some of the things that are beyond human understanding, it would come and show you, okay, the person have done this is what the person is trying to do in that direction. But the main agenda would to be policy as a code. So you treat coding or pushing your code into your development branch or your production branch not only as peer review, but have a proper structure for it, in attached with the security, risk implementations, and writing unit tests and all those things, making sure that you stay protected. And more so, with the help of GuardDuty coming from AWS, you're able to do a continuous model behavioral monitoring, making sure that at every step of the way, any changes that happen within your system, you identify them and you catch them at as early as possible. And lastly, this technology is being used in the military space, if you are familiar with that. So what we are adding here is to do what? Is to add natural language processing in identifying all these signals, so these telecommunication waves, all these radio waves, and binding them to what? To natural languages, and making sure that we identify these patterns, or we identify the sentimental behavioral around what the person is saying, and making sure that we detect the system, whether it's fraud or it's not fraud or is neutral. And that would be it. So lastly, I would say what I'm trying to build, or what we need to do, at least in the telecom industry, or maybe in every industry, is to see this is not about stopping fraud once it happens. It's about preventing it as it happens on a global scale. So making sure that everything all the risks that happens in real time, for us to get, or for us to stay secured in that direction. Thank you very much for having me, and you could scan my LinkedIn and connect with me, and also I'll be very happy for you to give me feedback on this talk, and this would help me in further indulgence. Thank you very much.